So perhaps that's a little bit too complicated for you. Well, let's do this in a little bit different way then. Let's insert some fraction bars into the drawing. If we look at the triangle on the right there, we've got 9 and we've got x. And I'm going to put a fraction bar in between those guys. Now what I want to do is I'm going to insert a fraction bar in the other drawing the exact same way. Now the catch is that has to be oriented the same way. And indeed, if you remember back to the beginning when we started this question, I said that was something you should do. I said that if the right angle was in the lower left, the other right angle should be in the lower left. And that's the way these are drawn. And since that's true, we'll use this technique the whole way. I'm going to insert the other fraction bar in the exact same way. So since this one goes like this one's going to go like this. And then I'm going to stick an equal sign between them, and I'm going to write my proportion. 3 over 4 equals 9 over x. And that's the proportion I'm going to solve there. Notice it doesn't take a lot of time of me writing out sides that match up and then changing them in numbers, because I already did the matching up of the letters by drawing them the same way. And then because I'm picking the left and the bottom and the left and the bottom, I've already got them matched up anyway. Now, I'll talk about why these are the same, even though it's got a little bit different setup than this in a minute. But notice what I didn't do is I didn't do anything on this, what would be the hypotenuse of these two triangles. A couple different reasons here. A, most importantly, there's no numbers there. All right, I don't have a number here. I don't have a number here. Okay, so I don't know anything about the relationship that exists there. But secondly, they weren't asking me to solve for anything there either. I don't need to use something that they're not asking me something about or haven't given me something about. So there's no reason for me to pick the hypotenuses here. Okay, so now you're saying, well, that's different than the proportion that's on the screen. Well, is it really? Because remember, on this one diagonal, we did 9 times 4. And indeed, when I solve this one, look at that. There's 9 times 4. All right, 9 times 4 giving me 36. On the other diagonal, I've got the 3 and the x. Well, remember, the other one, all right, also had 3 and x. It was just in a different order. So even though it's set up a little bit differently, indeed, this is actually me solving the same proportion, maybe even a little bit more quickly and easily than what they did. Here's a third thing I can show you, a third way to approach this. They're saying that these guys are similar. Well, look at left side to left side here, 3 to 9. 3 to 9 means I'm multiplying by 3. Because we're telling you these are similar, that has to work all the way around no matter what. So when I go bottom to bottom here from left to right, that means multiplying by 3 also has to work. 4 times 3 is 12. What answer did we get? 12. So there's lots of different ways you can approach this. If you like writing it out and then changing it out to numbers like they did, you do it. If you can see that multiplier and that works out easiest for you, do it. If it's a matter of just taking the drawing and inserting the fraction bars and equal signs, do it. Whatever works for you and whatever you're comfortable with is going to work here. All right, here's question number 2. Question number 2 says that a 30-foot building casts a shadow that is 75 feet long. A nearby tree casts a shadow that is 35 feet long. How tall is the tree? So where I would start here is actually what they've done in step 2, which is the drawing. Right, you've got a building that's 30 feet tall that casts a shadow that's 75 feet long. You've got a tree that's in the close vicinity. We don't know how tall that tree is, but we know that its shadow is 35 feet long. And we're supposed to figure out how tall this tree is. Now, as you can see, they've got this third side here that's this dashed line, because that's how you're going to get your similar shape. That makes it a triangle. That line would actually be the sun's rays, because that's how we're going to be getting a shadow here. Okay, so let's see what information we've got. The answer to the question is going to be the height of the tree, because the second statement there, or rather the final sentence there, the third statement, how tall is the tree, is what we're trying to find. The height of the building is 30 feet, given to us in the first sentence. The length of the building shadow is 75 feet, given to us in the first sentence. And the tree is the tree shadow is 35 feet long, given to us in the second sentence. All right, so we've already made our sketch. We talked about that right in the beginning. So let's talk about solving this here. We have two similar triangles. That's why it's in this section. That's why it's in this presentation. And notice they're oriented in the same way. You've got the height on the right side of each shape. You've got the shadows at the bottom. You've got the dashed lines, the hypotenuses going the same way here. So you've got them oriented the same way. And now we're going to solve the proportion. So remember what I talked about in the last question. I talked about going ahead and just inserting some fraction bars and an equal sign in the same way in each drawing. So I'm going to insert my fraction bar here like that, h over 35. Remember, when I do my other fraction bar, it's got to do the exact same thing. So it's 30 over 75. And I'm going to set those two guys equal to each other, and that's what I'm going to solve. Well, as you can see, that's exactly what they have written here. They didn't have a letter order to go on because there was no letter order, so we just had to figure it out. But look what they did. They compared heights in the numerators here, and they compared shadow lengths in the denominators here. Again, talking about that idea of unit consistency. So we can solve this any way we want, but what they're deciding to do here is cross products. They're saying on this one diagonal that you've got 30 times 35, which is 1,050. And on the other diagonal, you've got 75 times h. Well, that also has to be 1,050. So I'm saying, what would I multiply by 75 to get to 1,050? Well, as you can see from the equation being solved here, 14 is the answer, because 75 times 14 is 1,050. So the missing length here, or in other words, what they're asking us to solve here, the height of the tree has to be 14 feet tall. And that's the solution to our story problem. For the 30-foot tall building casts a 75-foot long shadow. That means the 35-foot shadow belongs to a 14-foot tall tree. And here, as you can see, they're finishing up that word problem by taking a look at those two ratios. They're saying 30 over 75 is equivalent to 4/10, and indeed that other fraction worked out to be 4/10 here. So 14 and 6 being related by 4/10, that means that our ratio, our proportion, our solution works out to be valid. All right, let's go ahead and take a look at the check it out examples here and conclude this presentation. They're saying that triangle MNP and RST are similar, and we're supposed to find the length of side RS. So if MNP and RST are similar, and notice they're oriented in the same way, that means the scale factor that relates these have to be the same. Perhaps you don't know 18 to 27, but it's actually not that difficult. To go from 18 to 27, we'd be multiplying by 3 over 2 or 1.5. So the same multiplier is going to have to work here when they're asking me to find the left sides. And when I do 10 times 1.5, we get 15, which we know is the answer. But let's say we didn't know that. Let's go ahead and do the solving here. We can go ahead and write a ratio that compares the sides, but let's skip the other way, skip that way and go to the other way is what I'm trying to say here. Let's go ahead, and since these have the same orientation, let's just insert fraction bars into these the same way. I want to write a fraction that compares the left and the bottom, 10 and 18. So over here I'm going to write a fraction that compares the left and the bottom, Well, the left I don't know, so there's my variable x, and the bottom is 27. So 10 over 18 has to be the same as x over 27. So on this one diagonal, I've got 10 times 27, which is 270. On the other diagonal, I've got 18 times x. So I'm saying, what number would I multiply by 18 to get to 270? Well, it doesn't surprise you because, again, we see the answer on the screen. 18 times 15 is 270. You can verify that on a calculator, but either way, doesn't matter what we do, we know that this missing side length here has to be 15, as in 15 centimeters. Again, we don't do anything with this hypotenuse, this right side here, because they didn't give me anything about it, and they aren't asking me anything about it. The sides we use are the sides that they either gave me information about, in this case the bottoms, or the sides they're asking me something about, in this case this left side over here, which forces me to use this left side number over here. That hypotenuse doesn't help me at all. We know that the relation between the two is the same, that this one is 1.5 times larger than this one, but since I don't have any numbers and they're not asking me anything about it, that's all I can say about it. All right, let's go ahead and take a look at number 2, and what we see missing in number 2 is a sketch. So I'm going to scroll down here just a little bit so I can end up making a sketch so we can see how these two match up in the exact same way. Number 2 says a 5-foot tall student cast a shadow that is 7 foot long. So I got a student that's 5 foot tall, and they're casting a 7 foot long shadow. Then you've got a light pole nearby, which we have to assume that the light pole is taller than 5 feet, which would make good sense. Okay, there's my light pole, and we don't know how long or tall the light pole is, but we know it casts a shadow that's 21 feet long, and we're supposed to figure out how tall the light pole is. So since we're talking about casting a shadow, the rays of the sun make the third side here to make these triangles, which is how we can talk about these being figures here. We have our drawing made now, which helps us because we're going to do just as we've done in the other problems, since we don't even have a letter order to go on here, unlike the problem we did just a minute ago. We're just going to insert fraction bars in the same way. So left and bottom compared to left and bottom. Now my left over here is what I'm finding, so that's where I'm going to throw a variable into the mix, x. So I'm going to say 5 over 7 is got to be the same as x over 21. Again, what's important there is that these have to be oriented the same way to get away with that. And as you can see, I did. The right angle, for instance, is in the lower left. The sun's rays are tallest at the left, shortest at the bottom, or the angle of the sun rather. Tallest over here, tallest distance, shortest distance is over here. If you don't orient them the same way, you won't be able to get away with this because the drawings won't match up. But if you draw them the same way, turning if you need to, it will work every time. So left side to bottom is the same as left side to bottom. 5 over 7 is the same as x over 21. Well, on this one diagonal, 5 times 21 is 105. So the other diagonal has to then make 105. So I'm saying, what can I multiply by 7 to get to 105? Well, 7 times 15 is 105. So the missing height here has to be 15. Now, if you're looking at this question, you're saying there's an easier way. You're right, there is an easier way. The relationship between 7 and 21 is that I'd be multiplying by 3. So the same multiplier has to work for these heights here. To go from 5 to 15, I'd also be multiplying by 3. Since the same multiplier works in similar figures all the way around, since it worked here, it had to work here, or vice versa, we can find any side lengths with that same comparison. Since we knew 5 to 15 is multiplying by 3, 7 times 3 would give me my answer, or since 7 times 3 rather is 21, 5 times 3 gives me my answer here, which is 15.